Dear students, now I'm going to show you the skills you will learn in the second class. If you run the robot controller, first of all you will see the window like this. This icon means that now the manual control is not possible. If you press the button next to this icon, you obtain image like this. Now you can control the robot by the use of the mouse or of the joystick, and if you press it once again, you obtain such an icon. Now you can control the robot by the use of the buttons. And I suggest you to use this option. On the second classes we will have two tools. The first one is the pen, as you well know, and the second one is a reference frame made of wires. And of course the third one is the gripper, but this is not the subject of our interest in these classes. As far you know the method of the tool calibration by the use of 4 points, and you needed to approach the reference point 4 times, and the second classes you will be familiar with two another methods. The calibration by reference and the calibration of the tool orientation. So in order to be able to present the tool orientation, we need to have the reference frame of the tool, and this will be the reference frame of the tool. So in fact the tool is not present, and there is also only the reference frame of the tool. The first step of the classes will be classical tool calibration by the use of 4 points, and you need to calibrate the pen in order to obtain a precise tool, a precise pointer, which can be used for measuring different points, different objects in the robot's space. So you choose setup, measure, tool, and once again right arrow, and you will see the options of the tool calibration, and first of all we choose XYZ 4 points. You need to choose the tool to be calibrated. I have chosen number 10, and this is the name of the tool, and these are current dimensions of the tool, and after the calibration process these dimensions will be changed. So we press tool OK, and now we have instruction: line up the tool to a reference point from different directions. Direction 1. We move the tool to the reference point and press point OK. Then we get window quite similar with direction 2. We change the orientation of the wrist of the robot and approach the reference point second time and press tool OK. Third direction, can be like this. Again, point OK, and direction 4, like this. We press point OK last time, and we obtain calibration result. So these are dimensions of the tool X, Y, Z, and this is the error. So you can see that the error is less than 1 millimeter. So I have done it quite precisely. And now we need to press save. You can see that now the current tool in the system is number 1. After pressing save, the tool switches to number 10. After that, after the calibration finish, we should keep the pen close to the reference point, switch to global reference frame, press deadman switch, and now you have access to 3 angles of rotation, and try to rotate the tool and observe if the end of the pen stay at the same place continuously close to the reference point. If it is okay, it means that the tool is correctly calibrated. So as far it was the subject of the first classes, and now we continue the calibration process. Now we are going to calibrate our reference frame made of wires. So we choose setup, go here to the calibration options, calibration methods, and we choose XYZ reference. The system allows us to choose the tool to be measured, to be calibrated. Of course, now the number must be different than 10, yeah? It's very important. Under number 10, we have pen, and under another number, there should be the new tool made of the wires. So, if we have number 10, we should take a photo of this. The dimensions of the tool number 10, which has been already calibrated, are necessary for the next process. So it is most convenient to take simply a photo. If you want, you can take a notes, you make a notes. Okay, and then you need to change the number of the tool. So in my case it will be number 11, and the name of the tool, wireframe. And then we press tool OK. So this will be a new tool which now we are going to calibrate. Okay, the tool number 11 is fixed, and now the question is enter the dimensions of the reference tool. In our case, the reference tool is tool number 10, the pen which has been already calibrated. So the dimensions of the pen must be inserted here in this procedure. Yeah, you don't need to draw all the numbers. This accuracy is enough. Okay, so we press here data OK, and now move the reference tool to a reference point. So this is our reference tool, which can measure positions of the objects in the robot's environment. Now the tool is calibrated so the robot can use it as a measuring tool. And we approach the reference point, and after this approach, the robot can measure where is the reference point. So in this method, the robot will know where is the reference point. And we press, of course, point OK after that. Next instruction is move the tool to be measured to the reference point. So now we move our wireframe to the reference point. And then we press point OK. And that's all. We've got now the calibration result. So we can see that in this method you need to approach reference point only once, because the system knows where is the reference point. So that's the difference. If the reference point is random, we need to move the tool to the reference point 4 times. If the reference point is measured, we need to move the tool only once. We press save. The system switches to tool number 11. And now please keep the origin at the reference point. Switch the motion into the global reference frame and run the rotation of the tool and check if the origin of the coordinate system is at the intersection of the wires. Yeah. So we have tool number 10 at the end of the pen and tool number 11 at the intersection of the wires. So it should rotate around this point. Okay, so we have calibrated the position of the TCP, tool center point, and now we need to calibrate the orientation of the axis of the tool reference frame. So we come back once again to setup, and now we choose the calibration method, which is responsible for the rotation calibration. So ABC 2 point. We need to choose the tool to be measured. Of course, it will be 11. It's our wireframe. Tool OK. And next instruction, move the TCP, tool center point of the tool to be measured, to the reference point. So that's it. This is a separate method. So in this method, at the beginning of this method, the system don't know where is the reference point. Yeah. So first of all, the system needs to measure the reference point once again. So we approach the tool center point to the reference point, and system measure the reference point. Yeah. This is because of this this step. We press point OK, and next instruction, move any point on the negative x-axis of the tool to be measured to the reference point. And in my case, it looks like this. In my case, x-axis will be here, y-axis will be here, and z will be here. So this is negative part of the x-axis. And I press, of course, after this approach, I press point OK. Next instruction, this is last one, move any point with positive y value on the xy plane of the tool to be measured to the reference point. So xy plane. In my case, it's how to draw it. This it's a half plane because we need positive y value. So here is x, here is y. Well, I haven't got a plane at my tool, but I have y-axis, and in fact the y-axis belongs to the half plane, to the xy plane. So I can move the point on the y-axis to the reference point. And it's done here. I press point OK once again. And this is the result of the calibration of rotation of the tool. So all the process is divided in two separate independent processes. First, we have calibrated the position of the tool center point, and then we have calibrated the orientation of the reference frame of the tool. And now we need to press save. Please remember pressing save, because in other case you will lose the result. And now you can verify if it is correctly calibrated. You need to switch to the tool reference frame, and you will move the robot, you will move the tool in the tool reference frame. So X will be the motion in the X direction of the X axis of the tool, and so on. And now I can show you how it should look like. The movement along x-axis, the movement along y-axis, and the movement along z-axis.